Good morning, ladies and gentlemen. I have a lot of stuff on my desk, and this time I'm really playing with junk because, for example, these LED panels here, they come from old stage lights, which I didn't repair because buying new ones was cheaper than repairing anything, but the LEDs are still good. There's not much on about that. Then I thought I could make some RGB lights for my videos, and I bought some RGB controllers and a remote control with 1, 2, 3, 4 individual channels, and I also have 4 receivers. I only need 3 because I only have 3 LED lights. Then we have 3 sets of batteries, lithium ion batteries, the 18650 types. I made them at work with my little welder here. They are also recycled. They are from all kind of devices, probably from old laptops or whatever. And the other only thing that is new are these balancer boards here. Those are balancers for 5 series lithium ion batteries. And I even got one as a free sample as a gift. That's nice. Yeah, let's build that together and see how it works. So these protector boards here come with charge protection, discharge protection, and balancing. And as you can see, we have 4 places for these MOSFETs, but only 2 are populated. So this is the 5 amps version. If there are 4 MOSFETs here, it's the 10 amp version. Then we have power output here, P plus and minus. We have the highest battery voltage here and the lowest battery minus here. And that's the intermediate voltages because we have to monitor every single cell here. What you can probably see is they have soldered some nickel pads here that makes it possible to directly weld this battery nickel stripes directly to the PCB. But I plan to solder the connection, so I will remove this these pads here. Yeah, let's do that. So that's the battery itself. I took the same types of battery for these packs because I think mixing different types and different strength of battery with different amp hours and stuff is not very clever, so I took the same ones. It's a battery type from Samsung. They are usually not bad. We have some other batteries, used ones that came from HP servers. They were used for the cache memory for the RAID controller. Those are blue, and I don't know what the manufacturer is, but these fail quite often and they go completely dead. It's like a piece of wood. They do not accept any charge, they do not have any voltage, in fact 0. And yeah, these are pretty good, and whenever I have some of them, I collect them, I put them on the side, and when I need some, I have them for free. That's nice. Now the balancer board is exactly the right size to go on top of 5 batteries. That's why it has this shape. So at the end we could put some heat shrink tube around it, and yes, it looks like a professional battery pack. So the first step will be to solder some wires, because we need a connection here, 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 and also here and here and here, so that every single cell is connected to the board. Now, can we do something clever? We have the minus here and the plus there. I could, if I wrap that around, and if you're working with batteries like that, you always have to keep in mind they are charged. And even if they are not really charged, they are never 0 volts, so we always have voltage, we always have some power, and if we are not careful, we could short out something and destroy something. Yeah, that could work. No, I don't like it. I think I take another wire for that. Now the first battery pack is finished. Let's see if it actually works. So we should have, these are almost fully charged batteries, so we have 4 point something volt per cell. We should have about 20 volts in total. And as you can see, that's 10, 20, 30, 40, 50. We are on the 50 volt range. It's, well, 21. Okay. That's nice. Then one battery is about 4 volts. Could have that a little bit better. 4.2 volts. Okay, not exactly, but almost. Pretty much fully charged. Then the next battery, it's 7.4 volts on the PCB, but when it's fully charged it's a little bit more. We have 8.23 volts. Okay. Then the next should be about 12 volts. Yes, that's 12.5. Then we should have 16 volts. Yeah, almost 17. And of course 20 volts. And now the interesting point or part is, do we also have voltage on the output connectors here? Yes, almost 21 volts. That's nice. Seems to work. And I didn't destroy it when I solder it. Let's connect one of the receivers. These RGB controller and remote receivers are pretty simple. You have a power input here, 2 screws, goes here, or you can use these barrel connectors. They accept 12 to 24 volts. I tried it out already and I found 20 volts is about the best for my LEDs. With 24 they get a little bit hot because that's not a constant current controller, it's a constant voltage controller, but that's also not entirely true because you can dim the lights, so the voltage and the current goes up and down. So it depends a little bit on the input voltage, what kind of LED you can connect, or the other way around, what kind of LED you connect. You have to adjust the input voltage, but if everything works out, for me it works out at 20 volts. That's why I took 5 lithium-ion batteries, because when they are fully charged they have about 21 volts. When they are empty they are, I don't know, 18, 17 volts or a little bit below. Then on the other side we have common plus. There are 2 connections, they are the same, you can use both for the common plus. It depends on how many LED strips you want to connect. There's a bunch of different connection schematics. It's in the user manual, and it actually comes with a user manual, so you can use one RGB strip. That's about what I'm using here with RGB and white. You can have 2 dual color LED strips for whatever reason. Or you can have single color LED strips, but 4 of them, and yeah, you can mix and match whatever you want. The user manual is not too bad. Of course, it's a Chinese English translation, but with a little bit of fantasy and imagination, you know what they mean. The most important part is how to match the remote control to the receiver. As I said before, we have here 4 zones or 4 different receivers. We can say receiver 1, set it to red, green or blue or white or whatever, or use the color wheel here, which is really nice. Or if we want to use all together, we can press 1, 2, 3, 4 in rapid sequence, and then all will work together. By the way, the remote control is not infrared or anything else. It's wireless. It's 2.4 gigahertz, a wireless remote control, radio wireless. And let's connect it and see how it works. By the way, for those who are interested, this old Simpson multimeter is something I found at work. Somewhere in a drawer. It has never been used. That's why it looks like new. It has no scratches at all. It always sat there in the drawer and waited for me. It's not as old as it looks. I mean, from the look, from the design, it could be from the 1950s. It's a 1983 model, I think. That's the original warranty card and operator's manual. I always think, what happens if you send this card in? Does the company still exist? Maybe, maybe not. Yeah, here. December 83. It's the 4th edition. And yeah, it works. It's astonishingly accurate. All the ranges work. The ohm ranges, it needed fresh batteries, of course. The old were absolutely zero. But there is nothing inside this that could go wrong with the time. There are resistors. There is one large switch. Of course, the switch could corrode, but it didn't. And the resistors, they do not change. And there are, I think, 2 diodes for the AC voltage range. And that's it. A multimeter from 1983. And now the run LED is already on. I just remembered I also need an on-off switch, of course, because this thing has none. And yeah, it will drain the batteries sooner or later. What we can do now is to match these 2 parts. So let's say this should be number 1. I press match, press number 1. And the blue LED did flicker a little bit, so that means we are paired. Well, maybe it's not clever to connect power before I connect the LED, so I remove that again. I just wanted to have these 2 wires a little bit separated, not that they touch. Well, we have an overcurrent protection of 5 amps, so nothing bad can happen, but better be safe than sorry. Okay, now we have wires. Funny part, we have a red wire. This is of course for the red light, blue wire for the blue lights, green and white, and the black wire Well, I think because red is already reserved for red, that's positive. So that's a little bit strange, but if you know it, then you know it. So that's positive black. And by the way, I have seen many lights with the same colors, and black is always the positive. And you can also see it here. Black goes to W positive, so it says white positive, but I think all the positives here are connected together anyway. Maybe not, but anyway, it's the only wire with a plus sign here, so that's the positive. Then we have red. Red. Where is it? Here. Goes to then we have green goes to G. G is written G-E-E, and according to ChatGPT there are multiple E's in an alphabet because G and B and everything is E. Yeah. That was a joke. No, that was not a joke. That was an experiment from another YouTuber. He asked GPT how many double characters are in the alphabet, and ChatGPT told him that some, like for example E, come multiple times. And it was pretty difficult to convince ChatGPT that that wasn't true. Okay, so now we are up and running. So in theory, if I press 1, green goes on, I say red, okay, red, green, blue and white. Interestingly, if I press white, it's always the last color plus white, so if I use red, white, so it's red and white, green and white. I don't know if you can see that in camera. Let me adjust that a little bit. Okay, again, red, red and white, red without white, green, white on, white off, blue, white on, white off. There is a trick. Oh yes, I can. If I turn it off and I turn it on with white, then I have white only. That's a little bit strange, but if you know how it works, yeah, that's how it works. Then we can use the color wheel. You see, I slide it around. Yeah. And for example, if I take the R button and keep it pressed, it will dim until it's off, and I press it again, it dims up. So I have all possibilities, and I also have two memory storage 1 and 2, or scene 1 and 2, so I can memorize some settings. And through the power of fast forward, we already have 3 working units. Now I have to pair number 2 and 3, and that works as follows. I press the pair on 3, and I press the pair on 2. Alright, I already labeled them 1, 2, 3, so that's why I rearranged it. Let's try it out. 1 red. Okay, it's already red. Let's take green. 2 blue. And 3, yeah, red. Or white. Then if I press 1, 2, 3 and press green, they all turn green, and they all turn red, and they all turn blue. Yeah. And if I use the color wheel, they all go through all the colors. And if I push the off button, they all go off. So that's how that works. So the next step will be to create some sort of housing for these lights. So lying flat on the table, they have not much use. You may ask why I need these lights anyway. I used them the first time with my April 1st video about the American iPad. Maybe you have seen that. And I noticed that, according to the comments, not everyone is familiar with April 1st jokes or April Fool's jokes. And well, I so know that people in Asia, for example, don't know what that is, but it was an American guy who asked me, what's about it? Is that a joke? And I said, yes, April 1st, and he didn't know. So let me know in the comments, where are you from? Is April 1st jokes or April Fool's jokes, is it a thing where you live, or is it not? You don't know what it is, or, well, just write it in the comments. And that's enough for today. Thanks for watching.